And I am now recording. The day is July 19th, 2018. The time is, well, 6:02, and this is the regularly scheduled broadcast of the ITSE 2309 show, coming at you live and direct from Collin College. Well, wherever I am. Tonight we are in Module 11 and dealing with Chapter 9 in the textbook. So this deals with functions. Now, the functions I'm talking about here are not functions that we write, like the function f of x is 3x plus 7 or something like that. These are built-in functions, and we're going to talk about later in your study of SQL and the programming language. We're going to talk about functions that you can define like a C++ function or a Java function, and we have that available to us. But these are a little bit different. These are ones that are provided to you within the programming language. And let's talk a little bit more about that. The reading assignment is 263 to 283. And then I talk about some other stuff. For right now, I'm going to stay within this range, 262 to 283. And we're going to talk about, first, we're going to talk about functions designed to manipulate strings. And let's, and then manipulating numeric data, and then manipulating dates. So first of all, let's start with strings, and then I'll come back to this page. Next, built-in characters. SQL Server provides a number of functions for working with string data. And there are some problems that come up in this, and that is numeric data stored as character strings does not sort correctly because the string 77 sorts as greater than the number than 695, even though 695 is clearly greater than 77. And we have some issues when we have a first name and a last name stored in the string. I'll let you look at this tutorial. It's good. I hope it amplifies that. And we're going to talk about a couple of things here. We're going to talk about functions that return information about the string passed as the argument. These are called observer functions. And let me show you an example of these. I have something open here, so I'll just run it. Select the length, L-E-N, the length of the vendor name. How long is the vendor name? From vendors. And I should get some numbers here. I'm getting and I always have to select the database I'm using, if I can get it done here. And when I finally get that done, as I do this, I will get some, so I can select the length vendor name as the length don't like using a name that turns blue. So let's look at it. I want to see the vendor name and how long is the vendor name. Now, how long the vendor name is, how many characters are in the vendor name, should be obvious if I select the vendor name, but POOH has 4. U.S. Postal Service has 17, whatever that one is. National Information Data has 29. JobTrack has 7, and so on. Here's one, ASC space signs. Notice that the space counts, and so on. And so I can get the length of a field by using LEN. Now let's go back here. So this would be how it would be used if I wanted this for some reason. So I would say select vendor name. Well, let's see, what is from vendors, and I'm only interested in short names, so I'm going to say where length of vendor name is less than, let's say 5. And I didn't get that. Is less than 5. So where the length is less than 5. So if I were to execute this, I'm only going to see very short vendor names like POH, IBM, AT&T. They have length of vendor name less than 5. So this one has 4 characters, 3 characters, 1, 2, 3, 4. And so if I change that a little bit and I said less than 10, I'm obviously going to see more names than that. So there I get 14 of them. And so this shows me names that are less than 10. So less than or equal to 9. So everything here has 1, 2, 3, 4, 5, 6, 7, 8, 9. If it's got 9 characters in it, it appears. If it has 10, it does not. Let's go back to this. So string functions that give us information about the string being passed as the argument, are called observers. So LEN, the length of a string, is a classic observer. Length function does not change the string. It just tells you some information about the string. How long is it? So it tells you how many characters it has in it. And then finally, functions that return a new or different string other than the argument. This type of function is called a constructor. Now we're going to see that if I concatenate 2 strings. So the concatenation function puts 2 strings together and returns them jammed together. We've seen that. You can replace something in them and stuff like that. Let's talk about the observers first. Observer functions, there are 3 of them that are the biggies. There are a couple more, but the big one, the really big gorilla here, is the LEN. That's probably the most commonly used one. How long is the argument to the string? How many characters are in it? Okay, some important points about it. It counts leading spaces. So if you have space, 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 IBM, that is 6 characters because it's 3 leading spaces. So it counts leading spaces. Space, 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 IBM, space, 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 is still 6 characters because it chops off trailing spaces. Suppose the string contained only spaces, it would be 0 length. Now, how can we use this effectively? What is the use for LEN that we have seen? Many times we would prefer that something that if you have a name, you can have a name, but I want your name to have at least 1 character in it. So if your name is null, that means you don't have a name. But there is a problem. You can have a name in computer science, you can have a name that doesn't have any characters. Oh, this gives us a pain in the petunias. That's not the same thing as not having a name. And so we want to check that the length of the field is greater than 0. Questions?
Well, when you say it's saying space IBM, does that mean we hit the space bar 3 times before typing IBM?
Yes, for example, if just let's say L name gets quote space space space. Okay, so there are 3 spaces there. The length of this one would be 1, 2, 3, 4, 5, 6, 7, 8. Okay. If there were spaces after it, they would not count. This is typical. This is the way lots of computer science applications work. They count leading spaces and they truncate trailing spaces. You will find this to be true in Java, in C. When you're working with string variables, they will leading spaces on a name or a string variable will count, trailing spaces will not. You find that over and over again. Questions? Okay, going back here. Suppose the string contained only spaces. Well, are they leading or trailing? They would be counted as trailing. Well, I guess they'd be both, but since they're trailing spaces, it would return a 0 length. So if the string contained only spaces, I guess it could contain tabs or spaces or tabs. It would return a 0 length. And the common way that this is used is we have a constraint, null name, check that the length of the last name, for example, is greater than 0. So I want to make sure that it is, instead of saying check that it is not null, if I say check that it is greater than 0. Now, if L name is null, the length returns null, and greater than 0 will return false. So that will also check for null. Does that make sense?
Yeah.
So this one, lots of times when I'm teaching it, I will teach it, say check that L name is not null, and then another one, check that L name is greater than 0. Actually, you do not need that check for not null if you're checking that its length is greater than 0, because if it is null, if L name is null, then L name is null, and null is not greater than 0, will return false. So this would throw out a null last name also. But you can check them both if you want. It's not wrong. Questions. Length. LEN. How many characters are in the string passed as the argument? Important function right there. Doesn't change the argument. It just gives you back a number that tells you how many characters you're looking at there. Very important little function. Next one is similarly important, return the char index, and every computer science program, every programming language has something like this. It has different names. So some of it has, PAT, pattern at, PAT, AT. I think in Java. And C++ is SUBSTR, substring. So basically, it takes a character called F, and F is the find string. So F is the string that is being searched. The first occurrence, wait a minute. Okay, it's backwards there. I'm backwards. Find this pattern in this string. Now you'll find that to vary from programming language to programming language. The order of these parameters might change. Obviously, I just got it wrong. So go out and find something, find F within string S. For example, find N, capital N, within the string my name. What should that return? It'll return its position. It starts counting at 1 important point. 1, 2, 3. Oh, there it is, 4. I found it at position 4. Not all programming languages start counting at 1. Some of them will start counting at 0. SQL starts counting at 1. Okay? If it finds it, it returns that value. So there was nothing, it did not have to be a single character. It could have been NAM and it would have still returned 4. Had it been NAX, it would not have found it and it would have returned 0. So if the substring is not found, it returns 0. So for example, copy. If I want to see something like that, I expect to see when I execute this statement, select char index n within my name, I'm expecting to see a 4. If I say select n a from within my name, I expect again to see a 4. If I say NAX, well, there is no NAX in that search string. So when I try to execute this, I'm going to see a 0 because I did not find that substring. Questions? This becomes quite important in many applications. If the substring is not found, it returns a 0. Most of the time, you know it. Most of the time, I use len and char index very heavily. By the way, there is a third optional parameter, the p, which is an integer that says starting at 1 and counting up where to begin searching. So let's do a test on that. Char index. Let's find foo in fee fi fo fum. It should not find foo in that search string because it is simply not there. So it will return a 0 that did not find it. And so let's change it a little bit, and let's put a let's put a foo there and a foo there. Now I've got 2 of them. The answer is, which one will it find? Well, it will find 1, 2, 3, 4, 5 is the beginning of the pattern. So I'm expecting when I execute it, I'm expecting it to return a 5. And it did. It started searching at 5. Now I'm going to tell it instead of starting at the first, I'm going to tell it to start searching at position 6. And now it will start searching here. It will not find the first one, the 5. That's 6, 7, 8, 9, 10, 11, 12, 13. I'm expecting to see a 14 now, because now it will start searching at position 6. Let's see if I see a 14. I see a 13. Let's try that count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is the correct number, not 14. So it found it at beginning at position 13. I should have known that the computer is probably better at counting than I am. The important point about it, it starts at 1. For those of you who are used to Java or C++ arrays and strings, you are used to them beginning at 0. SQL strings and arrays, for that matter, begin at position 1. Pausing. Pattern index, F and S is like char index, and I think the pattern index in most of them allow that third parameter. I would have to Google it and find out, but it finds F within the string S, but it allows you to use wildcard characters in the find string. I do not use this one as much, but pattern index, let's see if I can give you an example. So foo, you see, I believe it is a %. Find anything, so I'm going to find 1, 2, 3, 4. I should find 5 here. Fine. 0. Let's see, what is it? Is it a let me look that up real quickly. Pat index. Pat index in SQL. It's going to tell me all about it. Wildcard character, however, must come before and follow the pattern. Okay. TER. Okay. So I want to find anything that's got an FO in it. So that should be 1, 2, 3. Would help if I'd put a. And so I expect to find it at 1, 2, 3, 4, 5. I expect to find it at 5. So when I execute this, I'm expecting to find my first FO at, I'm finding it at 0. Why am I this? Pattern. Well, why am I not finding this one? So there's the sequence I want to find, FO, and would help if I'd get that right. Pattern index. So let's see if I get to 5 now. And there I get my 5. Now, because I found this one, FO starts here, so that let me do that. So I should find another one at 5, 6, 7, 8, 9. I don't know whether pattern index will allow me to start searching at 6 or not. No, it apparently is not. So it just returns the first one it finds. And so FO would also find all 3 of these, but the first one it finds will be this one. I don't use pat index that much. Okay, let me go back to this guy, SQL Server. Where was I? Here. Pat index. So when we were setting up our tables, the null string, so I would check that if I check that the length is greater than 0, that would also eliminate L names being null. You do not have to have both of these. This one only checks for null, but if I check for the L name greater than 0, I also eliminate nulls. It's okay if you write 2 of them, but for the most part, I would put this one first, and then that would throw it out immediately. Okay, another example of this would be the Smith family database. Only last names that contain the word Smith are allowed. Smith, Smith and Wesson, Smithwick, Smithers are valid. Jones and Smitty are not. So a constraint check that the char index of the string Smith in last name is greater than 0. If it doesn't find that, it will be 0. Now, whether or not the search is case sensitive depends on the server settings and how you have it. By default, if you just do a default server installation, string searches are not case sensitive, but you can change that fairly easily. String constructors. These guys are going to change the string. So they return a string that is different from S. They do not change S. This is the important part. A function, I'm not going to say never, but I'll say never. A function never changes its argument. A function never changes its argument. A function returns a string that is different from its argument. For example, ltrim left trim, in other words, trim the stuff off to the left. 3 spaces, foo. So I'm saying trim the left stuff off. Now, this string will still remain the same. If this were a variable, if this were a field, it would not change it. But what it would return is foo without the stuff on the side. If I just said to select this, then you would get it back with the spaces. Okay. Commonly, you do not want the spaces. You do not want leading spaces. You do not want trailing spaces. So we have ltrim, and we have r left trim, right trim. So right trim acts first. Right trim chops off the spaces to the right, and then ltrim acts. It really doesn't matter which one of these you do first, and what you're going to get is the argument with all of the leading and the trailing spaces chopped off of it. This is real common. Now, many are them that will provide trim, just plain trim. And now that's giving me I'm surprised this isn't giving me an error. This must be something new because SQL Server 2012 would have given me an error. I'm in 2016, so I guess this works. There it is. Trim is not recognized in this guy. So if you want to do trim, you have to put ltrim and rtrim together, which isn't a big deal. You say trim the left trim, and then from that, okay, first thing that happens is that the right trim happens, and then it trims the left. Doesn't matter what order you do them in, this will trim the spaces, leading spaces and trailing spaces, which is usually what you want to do. Questions?
So you are saying that if you switch L trim and R trim, still
They won't change anything.
Okay.
It won't change anything. So right trim, so this says L trim, what you get back from R trim is going to chop off these guys. L trim is going to chop off these guys. If you change them, L trim first, you'd chop off these guys first, and then R trim would come in and chop off these guys. It would make no difference at all. And in SQL Server, if you want to chop off spaces on both sides, you have to use them together. We do not have just a plain trim. Other databases do. R trim, L trim. Okay. We have used this one, the left. Give me a string containing the specified number of characters from either the left or the right, so they both work the same way, of the string pass. So give me the left 3 characters. So we found this to be left what 940 12324-1212. Okay, there's a phone number. Now, how many of these guys do I want? Well, if I can, comma, how many do I want from the left? Well, I want 1, 2, 3, 4. I want 4 of them so that I can get that's the area code. So I want the 4 of them from the left. And so I got my comma, or my open parentheses, and 940. But I don't want that parentheses. So I'm going to select right, comma, 3 of that one. So I say go in there and get the left 4, and then go in and get the right 3 out of that, and this should give me the 3-digit area code, and there I have my 940. Questions? This is commonly done. So I know where it happens in there. I want to get it from there, so I want to get the left 4, and out of that left 4, I want the right 3. Make sense? I'll assume it does. Go ahead.
Can you go back to that example?
All right.
Yeah. In other words, what I was trying to, it does the inner one first.
It does. It works inside of the parentheses first.
Okay.
So it's going to do this one first.
Yes.
This one is going to give you back the left 4. So this one's going to give you back open parentheses 940. Now out of that, I want to take the right 3 and throw away that leading parentheses.
Now, if you switch the right and left, it'll give you altogether different answer.
Yes, it would. So that would say the left 3 would be open parentheses 940, and then the open parentheses 9, 4. So the left 3 would be, no, if I said left 3, I would get,
if we get it right,
I would get 2, 1, 2. And then, excuse me, I want the right. If I did this one inside, I switched the order of them. I would get the right 3 would be 2, 1, 2, and then I would try to take the left 4 of that, and it wouldn't have 4, but so it would just give me back 2, 1, 2.
Okay. So can you run and see that how that works?
Say again.
Can you just switch and run and see that how it works?
I suppose. I'm expecting to get 2, 1, 2.
No, not this one. Right and left switching.
Yeah, so if I change the left and the right, I expect to get 2, 1, 2 returned if I do that. I'm expecting to see 2, 1, 2 and 1, 2, 1.
Yeah, that's what we'll get. Right 4.
Okay, how did I get that? So take the right 4. Okay, this takes the right 4. There we go, right there. The right 4, and then the left 3. So that does give me the 1, 2, 1. So that's the right 4, left 3. 1, 2, 1. Yes, that's correct.
Okay.
Next one that we have is the substring. Returns a specified number of characters from the string beginning at position T. If I have a, so if I have something like this, and I can say select a substring, SUBSTR, am I spelling that right? Substring, okay, well sometimes it's STRING. The substring of how many characters do I want? Let's say I want 3 characters beginning at position 2. I think that will get it for us. So I believe that will give us the 940 also. Oops, gives us 94. 1, 2, 3. Okay, beginning at position 2, I want 3 characters. That ought to get me.
See, position.
So the position is the first one, and I think I've got that correct in the, so substring from beginning at position, the second one is the position, and the third one is the number of characters you want. So I say beginning at position 2, in other words, beginning here, give me 3 characters, and I get back the 940.
Yeah.
You can use either an, you can use whichever one you want. Sometimes one of them is better than the other. Sometimes substring and sometimes a concatenation of a right and left also works fairly well. For example, this one, had I said left 1, 2, 3, 4, 5, 6. What if I had said left len of this thing -1, and then right 3? Lots of ways I could have done this. So I could have said left, I want the left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I want the right 13, and then I want the left 3. This should give me the 940, and it does give me the 940. So either of these would have worked, or the substring would also have stripped out this area code, and that, by the way, that is called the area code. It's been a shock to me that students today sometimes don't know what an area code, when I say area code, what it means. Well, it means those first 3 digits. Sometimes they're in parentheses, sometimes they are not, and this gives us lots of trouble in database. We need to go in and strip out all of this stuff and just store straight digits, because all of these formatting, parentheses, and spaces and stuff like that really give us a lot of trouble. Okay, replace returns the string with all occurrences of the find string F replaced by the R. So find, replace. So if I want to say replace in fee fi fo, the find string, so I need to put a select on that. The find string is phi, and replace it with foo. So what am I expecting to see returned from this? Fee, foo, fo, because it's going to replace phi with foo. And there's the find string is fee, foo, fo, because this one in the find string, it replaced this with that. If it does not find that occurrence, it does not do anything. It just returns the string. Notice that it did not change the argument. So if this were a field of a table, that table would not be changed, but the return value of this function would be a new string with the replacement made. Does that make sense? Okay.
Yeah,
let me make an example. Select, replace, vendor name, and every place you find an S, I want you to replace it with XXX. So every place you find an S in the vendor name, replace it with XXX. Now, when I execute this, notice that I have a lot of things that have kind of weird values in them, lots of XXXs, but this did not change the table. The important thing is this did not change the table. The value of this function is the string with it replaced, but I have to insert that into the table before it's changed. So I could say update the table, set vendor name equals replace vendor name as comma XXS. In that case, it would change it, but the replace would change it, or excuse me, yes, the update to the table would change it, not the replace function.
Okay. Can we give it an alias name as new?
Yeah.
Okay, let's give it an alias name as new and replace new XXX with S. We should get back the same thing.
Yes, we would.
So I want to see if that is being treated as a string.
Well, I'm getting a string back, so I'm selecting a string. Now, if I were to say update vendors, set vendor name equals. Now, I really do not want to run this.
Oh, yeah.
Because if I do, I'm going to change all of my vendor names.
You could create a derived table.
Well, I could create. But if I do an update, that's going to change it. So it's like I'm saying, we want to be really careful with our SQL. We don't leave stuff like this laying around in our files because that is dangerous, and it will change that table, and it will update the vendor name, and all of the S's in the vendor name are going to get changed to XXX.
What I was suggesting, we could create a derived table and do it on that derived table.
No, well, you could do it. A select statement is fine. If you just do select, if all I did was say select, replace vendor name. So remember a moment ago, I just said this. This is a different varmint. So I said select. Select is fairly benign. This is okay because the select is what I said when I got this. So if I select that, what am I going to see? I'm going to see all the names with S's, P-O-S-T-A-L. It reads P-O-X-X-X-T-A-L. That's fine. That just, in this select statement, it replaces it. If I do an update like this one, I've just changed all my data. Because this guy right here returns a new string. And what am I saying? I'm saying set the vendor name to this new string that it replaced. This one, I'm just saying show me what the new string would be. And I don't think I use an as on this. I think that's the correct syntax. I don't want to run that.
No. Okay.
Questions? Okay. Let me keep moving along here. Okay, replace, concatenate. I don't usually use this. The concatenate function is also provided by the plus. But if I were to say select, select concat. By the way, select is how you print something also, and that's not a semicolon, is it? If I execute this, fee-fi-fo fum, I would get exactly the same thing if instead of doing concat for concatenate, I just said select and I put the plus sign between them, I would accomplish exactly the same thing. Both of these statements are exactly the same. If you put the plus sign between them, you get exactly the same thing, so they are equal. I usually use the second one, but you may use concat. Oh. Okay, let me move on here. Lowercase, uppercase, returns a string, same one passed only in all lowercase, and upper string is the same one passed only in uppercase. If it's not a letter of the alphabet, it doesn't do anything to it. So for example, if you said capital, if I said upper, upper Joe 1 2 3, what I'm going to get is the back but it's going to say J-O-E in uppercase. The rest of it is the same. Had I said lower, the J would have been in lowercase. That's the only difference. Questions? That's about all of this. Goodness gracious, it is 6:51. I'm going to move on. Okay, common string problems. I'm going to let you read this. Common string problems are when we have a number stored as a string. We find numbers stored as strings. The string 1, 2 would sort before the string 2 because 1 comes before 2. So for the same reason that A, B would sort before B. So 2 ways to work with it. The best fix is put in left padding of zeros. Instead of storing a 2, you store a 0, 2. And we'll figure out how to do that later. And the other one is to cast it to an integer. So if we cast it to an integer, order by cast ID as int, it will sort it correctly, given that everything in there is a valid integer. Now we have to worry about that because what happens if it isn't? The code will throw an error, and we can use the try convert function that we had last chapter. So I can say, hey, go in and find me everything where it doesn't work. So let's see, what am I doing? Contacts. I don't think I have a contacts one in there. This is a hypothetical table. But if we store the contact ID as a character string instead of an integer, I save a little bit of space, depending on how big it is. But generally speaking, a character string takes up less space than an integer does, up to a point. And therefore, it's common to do that. So it's common to store a Social Security number as a string. The problem with it is when if they're all the same length, everything's fine. If they have left zeros padding them out. So for example, if I have a 4-digit PIN number or something, and your PIN number is 1234, and my PIN number is 95, my PIN number will sort before yours. But if I pad mine out with zeros, so if my number is 0095, then everything's going to sort just fine. So if everything is the same length, we're going to be fine. The other option is to cast it to an integer. We talked about casting last chapter. Multiple values stored in a string. And we have to pull them apart. I'm going to talk about this one. I love this one as a question on a test or something. So we have last name, comma, space, first name. And the question is, first of all, does everything have a comma and a space in it? So I would first go through the data, and I would look for any non-conforming data. Do I have a comma and a space? Do I have at least one letter before the comma and the space? In other words, we begin searching at position 2. I'm looking for a comma and a space and at least one letter after it. And now I want to go in and pull out the first name and pull out the last name into 2 different fields. And this and here I talk a lot about that, selecting the substring. I'm going to let you look at that. I want to go on right now and get to the integers. Goodness gracious, where does my time go? Okay, integer discussion. Let you read that. Numeric. Okay. A textbook does numeric functions pretty well, but we talk about 2. If I have real numbers, or if I have talking about decimal numbers, what happens if I have a decimal? And we have the floor, which essentially chops the decimal off, and it gives me the next lower integer, the floor. Now, So what is the floor of 3.999?
3.
3. What is the floor of negative 3.999?
Still 3.
No, the answer to that is negative 4, because it always goes to the left on the number line. So the floor of negative 3.1 is negative 4. The floor of 3.1 is negative 3. So that's something to remember in that. So floor always goes to the left on the number line. The ceiling, and that is sometimes abbreviated as CEIL in many programming languages, but not SQL, ceiling, always goes to the right on the number line. So what is the ceiling of 3.1? Well, that is 4. What is the ceiling of negative 3.1? That is negative 3, always going to the right on the number line. Questions? There are 2 others that are not mentioned in the textbook that are commonly found. There is a fix, and it's kind of like 0, but it always goes away from 0. Okay, so if I x 3.1, well, it would fix upwards to 4. If I fix negative 3.1, that would fix away from 0 to negative 4.
Same as ceiling?
It's like the ceiling, except instead ceiling always goes to the right.
Oh.
Fix always goes away from 0.
Okay.
And then the last one that is commonly found is truncate, and truncate chops off the decimal. In other words, it kind of rounds, but it always goes towards 0. So truncate 3.6 chops it off, it goes to 3. Truncate negative 3.6 chops it off, it is negative 3. So truncate is the opposite of fix.
Is there not a round then?
There is a round, but that's, yes, there is. And it works like you expect it to work. Do I mention it here? I don't mention it. Round is there. Most of the time, if we want to see round, we will, when we print the value, we will round it to the certain decimal point for our readers. But we almost never round it in the database. We'll take whatever they give us and we put it into the database. But sometimes we need to chop off decimals. Sometimes we just need an integer. And so floor, ceiling, fix, and truncate take a number and give us an integer, whereas a round, I can round to any place value. But these guys, floor, ceiling, fix, and truncate, always give us back integers. Questions? Log, natural log. So if I say log of some number, what am I talking about? What is a logarithm? Well, back in your algebra class, you probably studied about the natural log, ln of x, and that's what this is. So it's the ln of the number. It is not the log base 10, the log base 2. But if I want to change to any base, I can easily do so. So if I want to change to the log n of any number, I take the log x and divide by the log of the base that I want. So for example, if I want a log base 2, I take the log of the number and I divide by the log of 2. So that's the base shift algorithm from your algebra class. I'm not teaching algebra. So for example, if I wanted a log base 2 of 32, well, it's asking 2 to what power is 32? Well, 2 to the 5th power is 32, so I'm going to get a 5 here. So if I said select log 32 divided by log 2, I'm going to be expecting to see a 5. Better see a 5. So if I were to execute this, I'm going to see 5. And there's my 5. Why? Because 2 to the 5th power is 32. So these are natural logs, and I can easily change, for example, 1,000 log 10, log base 10 of 1,000. 10 to what power is 1,000? 10 to the 3rd power. 10 times 10 times 10 is 10 to the 3rd power is 1,000. And I get 3. So I can change back and forth in these guys. So that's the real nice idea of the logs. Basically, I'd like to cover floor, ceiling, fix, and truncate here. If you don't do logs, lots of people have difficulty with algebra. I suggest you get over algebra if you're going to be in computer science. So you're going to have to do a lot of logarithms in computer science. We're not going to do a whole lot of them in here. If you get into my data structures class, you're going to call us the logarithmic kids. Okay, I'm out of time. I'm going to end here on the temporal functions. Temporal functions are handy. They give us a way to go into a date and just pull out the year or just pull out the month. And so they give us ways to work with it. Adding dates, subtracting dates, how many days are there between 2 dates, and a lot of stuff like this. So this gets kind of complicated here. I'm going to let you read that, and then I'm going to talk about this on Tuesday. I'm also going to, might run a little later on Tuesday because I am going to go over the practice test. So I will make the solutions available to you before class. And then we'll go over them.
Okay.
And you can argue with me. Questions? Okay, so we're going to end here for tonight. It is 7 o'clock.
Okay. Good night.
And good night. I am now ending the recording.